There are three types of tests you can do. First, back pressure or flow after flow test. So first you open the first choke, okay, choke one. You get on the upper chart, it is actually pressure, and then below chart is flow rate. So first choke, we have flow rate 1, and then we measure the bottom hole pressure by our pressure gauge, and then increase the choke again. We have this Q2, again increase the pressure, increase the choke, and then finally until the fourth data. You do this by the well testing, but the condition is this, the stabilized rate and stabilized flowing pressure has to be reached, which means that the well should reach or should approximate the pseudo steady state condition. We cannot do transient regime here. We need to achieve pseudo steady state regime. To know how long should we flow our well, we need to use this stabilization time formula. Is actually time required to reach pseudo steady state condition. All right. If you have porosity and the other data, then you can easily calculate your stabilization time. But if the stabilization time is too long, for example, if you have low permeability reservoir, most of the time TS will be very, very long. And we cannot do back pressure test. So we can substitute the test with isochronal test. It is quite faster. So you need to open your well and then shut in. Open it again, bigger choke, shut in again. Open it again, shut in again. Open it again, shut it again. The short flow period should be of equal duration. So the flow period should be of equal duration. Usually it is from 4 hours to maybe 7 or 6 hours. And then the shut-ins should be of equal duration until stabilization. So you still need to reach stabilization or pseudo steady state flow condition for your shut-ins. But the flow duration not necessarily equal with shut-in duration. That's the condition for isochronal test, okay? But the data is the same. You obtain your flow rate, you obtain the pressure. Lastly, to make it much faster and much simpler, we do modified isochronal test. Maybe this is the most popular and most practical to be done in the field. So you need to flow, shut in, flow, shut in, flow without reaching stabilization. Again, I need to mention that stabilization time means that the time required to reach pseudo steady state condition. You already noticed about the pseudo steady state condition previously, where the pressure wave hits all the reservoir boundaries, and it takes quite a long time. In modified isochronal test, or MIT, it's not Massachusetts Institute of Technology, all right? It's modified isochronal test. It's faster. So if you have 4 flow periods, it means that you obtain 4 data, right? Again, you plot it like this one, or you can also plot it like this one. This is in the linear form. This is in the original form. But the results is the same. You obtain the absolute open flow or maximum gas flow rate. This is actually your gas well performance or gas well deliverability. And if you are reservoir engineers or petroleum engineers or production engineers, this is actually, this analysis should be your priorities, maybe on daily basis, because your boss, your manager will always ask how much gas flow rate we can obtain from that well. And then what about that well? And what about the other? You need to do a lot of well testings, which is fine, provided that we have all the measurements, we can obtain all the data, we have the right softwares. All right, so far so good. We already discussed the introduction, gas volumetric, gas material balance, and then gas deliverability. So if we know already the deliverability of our reservoirs, the production system is actually like this one, okay?